Psyche is an M-type asteroid that currently resides in the asteroid belt between Mars and Jupiter. Psyche has been placed into this class of asteroids because it is believed that much of the mass of the asteroid is comprised of metals such as iron and nickel. NASA originally believed that this asteroid may be a leftover core material from a planetesimal. This theory has lost popularity over the years. However, Psyche still has various interesting attributes that scientists at NASA would still like to study. NASA originally had planned a mission to send a satellite to orbit the asteroid to analyze it from a distance, but that mission has since been delayed. In the future, NASA may decide to send a rover onto the surface of Psyche to further investigate this peculiar asteroid. The objective of this project is to design a power system that could generate a targeted power of 11 watts while having the system's weight stay under 46 kilograms or 100 pounds for a potential rover that is to be sent to Psyche to investigate the surface and environment. It is believed that this will have many similarities to previous NASA rover missions on both the Moon and Mars, and inspiration will be taken from said missions. The scope of the project is to design a system that will capture the energy loss from the rover while traversing on the asteroid, and it is designed to be an auxiliary power source to the rover using regenerative energy. The design must minimize weight and volume to reduce the overall cost of the power system as well as the cost of the initial launch. The design must also be durable enough to withstand the surface conditions of the asteroid, including its rough terrain and extremely low temperatures, and be self-sufficient in order to maintain itself on the surface while lasting the duration of the mission. The final design of the system consists of a ball-screw-based shock absorber attached to each leg of a six-wheel rover. These shock absorbers are connected to a gear train that rotates a generator to supply power back into the rover over time as the wheels move over the rocky surface. Each absorber consists of the ball screw, which acts as a mass damper, and a spring, which surrounds the ball screw that generates a restorative force, allowing the system to oscillate as it traverses the uneven asteroid surface. Plutonium, which is the current material used to power the rover via nuclear fusion, costs around $4,000 per gram and can generate 1 megawatt of power per gram. Our final design is able to generate 45.72 megawatts for the 2-year mission, therefore reducing the cost of plutonium needed by just over $182,000. The weight of the system was then added to determine the cost at launch due to the additional weight. The Falcon Heavy rocket is able to carry a payload with the cost of $1,500 per kilogram to low Earth orbit. Adding together the money saved on plutonium and the additional costs due to launch, our design is to save up to $550 for a 2-year mission, with possible additional cost savings for longer missions.